All right. Then, do you have any other examples of genomes like us? You said mammoth, but is there any other genomes?
So for genetic entropy,
Yes.
yeah, like well, the examples I gave, for example, was bacteria. So we see Lenski's E. coli experiment. He was looking to demonstrate the fish to fisherman evolution, adaptive gains, but we actually seen in that reductive evolution. Also, the H1N1 virus, we see that there's a linear accumulation of mutations that led to the extinction in 90 years, as well as Neanderthal. So there's more, we see data that they were highly inbred. They had a very high genetic load. I don't know if you're familiar with Homo naledi, Homo erectus. They were also both highly inbred and suffered also from reductive evolution. The mammoth populations, as you just talked about, yes, they carried an elevated genetic load. And in the human population today, a lot of it is epigenetic degeneration, but we see entropic degeneration on all levels, as I said before: Alzheimer's, cancers, asthma, autism, autoimmune diseases. So we see this genome-wide degradation in everything: viruses, humans, animals, bacteria. Does that answer your question?
Is there like any other like living animal that we can like check their genome and show that they are also declining like us, like living? I know you have less like viruses, but like animals, like giraffes or something.
I think we can see it. I think there's cheetah populations and dog populations. I mean, a lot of the changes, for example, like if we look to our model of created heterozygosity, a lot of the changes we'd expect to be due to a loss of information, just like Lenski revealed himself. So even if you look at, say, domestic dogs, going from, say, a wolf over time to something like a Chihuahua, that's the degradation of information. So the allelic diversity and the allelic potential in something like a Chihuahua versus something even like a Great Dane, it's been due to a loss of information. So in a way, that would be information loss as well, consistent with genetic entropy. I think everything we see can point us back to a time of least genetic entropy, which would be a time of creation. Points us right back to what Genesis says is God creating everything perfect. Does that answer your question?
You just listed two animals that have been affected by humans, which is the reason why they're suffering. Because humans have hunted down cheetahs to the point where they're suffering from a bottleneck. And dogs, for most of dogs, it's because of humans' artificial selection.
Do you have? So, are you saying because of the population bottlenecks, or say the inbreeding? Because inbreeding reveals, our genetic mistakes within the genome. So inbreeding, because I'll present a lot of evidence of genomic degradation, and they'll say, well, of course that's expected based on population bottlenecks, inbreeding, but inbreeding is like a sneak preview of where we're actually going genetically as species. So I think inbreeding is in population bottlenecks and the genetic degradation we see in those examples is certainly consistent with genetic entropy, as it is a sneak preview of where we're heading.
Right. You mentioned the heterogenesis of Adam and Eve and Noah. Would they be the same? Like, would they be the same level of heterogeneity or whatever?
Well, Adam and Eve would have been created with, because I always ask people, do you think God's command, be fruitful and multiply, was meant to be called out through cloning? So most people, 99% of people say, no, of course not. That's a weird question. So that was an indirect admission to the created heterozygosity model, because God would have created pre-existing DNA differences in the genomes of Adam and Eve. So through processes like recombination, gene conversion, and slightly due to mutations, the variation in genetic diversity would be quick. and would be rapid. But of course, the decrease of heterozygosity, for example, speciation would have been a lot more common and quick, say in pre-flood days, because there has been a decrease in heterozygosity. And a lot of times speciation is due to shifts from heterozygosity to homozygosity. So I think speciation events are going to be less common today versus say thousands of years ago. So yes, the answer would be increased levels of heterozygosity in Noah and in Adam and Eve.
So wouldn't we expect the same rate of degradation?
I'm sorry, can you repeat that?
Wouldn't their heterozygosity, whatever, be the same decrease rate? So there wouldn't be a giant drop exactly in the age after Noah's flood.
Well, the created heterozygosity was at the base level. So chromosomes, head-to-head comparison has different DNA letters on each pair. So that would lead to the diversification. But in regards to decreased levels of heterozygosity, as you're talking about, and say mutations, genetic entropy would have led to decreased lifespans based on the accumulation of mutations and based on even decreased levels of heterozygosity, even though I think that has more to do with genetic diversity, but also the environmental conditions, pre-flood versus post-flood. So a lot of the environmental changes based on the effects from the flood, I believe that too would have contributed to the decline in ages, because we see that in the biblical text. We see immediately post-flood. We see that, and we also see based on the accumulation of mutations that in the Levitical law is when Moses actually commanded and declared that, marrying close relatives would be against the law, because at the end of the day, we know that a big reason for that as well, other than being obviously immoral, would be the fact that those genetic mistakes could lead to diseases, obviously, like Down syndrome and whatnot. So we can see that post-flood as well. We can see that evidence there.
All right. You, in your rebuttal, you didn't really address any two points that I would have liked you to. But how would you account for the fact that we have silent genes in boars for teeth, and that we have activated them, and it has shown that they can form teeth?
So are you saying that these are genes in... You're saying they're silent genes? Are they non-coding genes that you're saying don't have a function, that were shown to have function? Pardon?
They were like turned off, I think, exactly.
Actually, can you repeat that a little bit louder?
The genes were turned off, so the genes to create the teeth were turned off.
You're saying that the genes were so not mutated, but they were kind of like because I know recessive genes on teeth, according to our model, would be part of the created heterozygosity. So I don't think that that's evidence either way. You know what I mean? When there's a competing explanation, that's why I gave the testable falsifiable predictions, because that's what would declare a more superior model. So are you saying it was a gene knockout which revealed this outcome that you're talking about? It was a gene knockout?
Can I just interject for a second and remind y'all that we have about 1 minute left for this portion?
Yes, thank you.
Basically, what I'm wondering is, why do birds have the genes to create teeth? That's my one point, basically.
Okay. So you're saying that the gene to create teeth it's like a pseudo gene. So it's not. It's kind of like the gulo vitamin C gene. Because
I don't know.
I think a lot of it, because, for example, you're assuming obviously mutations are the source of all variety. So I think with what you're talking about could be interpretation of the data based on the assumption, because we know that a lot of these genetic mistakes, recessive genes, pseudogenes, are actually now known to be functional DNA differences. So if it's a broken gene or if it's a silent gene, based on, say, ENCODE and what we know about the trajectory for genome-wide functionality, I'm not sure if I'm answering your question properly. And I know, like, Mendel's pea plants, if you look at Mendel, who did the experiments on recessive traits, it can also be applied to teeth. So, I mean, I'm not sure if I'm misunderstanding the question. I don't see it being a problem. I see it fitting quite nicely in with our model of created genetic diversity and heterozygosity.
Lifetime's probably almost done. But why would God even put genetic information to create teeth, but have it be useless or recessive or whatever? Why would he do that in boards?
Well, the thing is, we don't necessarily know if it is useless. Like, for example, they used to say that humans possess the broken remnants of an ancient chicken gene, but now we know after further genetic data that no actual remnant exists. This fragment actually is now known to be a functional DNA element. So what you're seeing here, if it is a pseudogene, with further research, or maybe it's even known now, it could be a functional DNA element, because we see now that 80% of our genome is transcribed, suggesting function, and a lot of these pseudogenes are being overturned. Of course, there are actual genes that are broken. You know what I mean? I had a Honda Civic and a Chevy Cruze, and the air conditioner broke in both the exact same spot. So that doesn't prove that they're related through common ancestry to a skateboard. It just...
All right, we are actually out of time for this portion, so we are going to switch, and standing for truths can cross-examine Godless Galaxy. And we'll start when you're ready.
Okay, awesome. I think, in regards to, because I know you talked about genetic entropy, I know it comes down to net loss versus net gains. Usually they'll resort to beneficial mutations can outweigh the deleterious mutations, but if we know that the rare occurrence of beneficial mutations cannot compensate for the information loss based on numerical simulations, based on the empirical evidence, what would be your one or two best examples of beneficial mutations that actually add new novel information to the genome? Go ahead.
I haven't entirely researched into beneficial mutations, which I can do later. But I probably always tell you these. But most of the mutations, I would agree that beneficial mutations can get rid of old mutations, like lactose intolerant got rid of some genes. But you also gotta realize that sometimes losing a function and gaining a new function can be gain than loss. So if a beneficial mutation outweighs the cost of losing that one function, it would be much better.
So, like, for example, the adult lactose tolerance, if that's what you're talking about, from my understanding, is due to a broken lactase promoter. So my question would be, if a lot of these examples of, say, beneficial mutations, because a lot of the mutations, if they're beneficial, a lot of them are environmentally dependent. If they're decay of prior information, loss of information, how is that going to compensate for the influx of deleterious mutations? Because if it's all about net gain versus net loss, how is that problem of genomic degradation going to be solved?
I haven't really researched genetic hitchhiking, but it is a selection that does happen. Basically, a group of mutations, a mutation would have like a group of mutations with it. I don't know entire statistics about it, but basically it would all be focused on mutation, which would increase the frequency of those genes around that one mutation that caused this, and the frequency would increase, and then those genes could possibly mutate more. I don't know, it's so much I was thinking about hitchhiking, but that's what I've learned so far.
No problem. If Because it seems like you're in agreement that a lot of what we thought of to be junk DNA is now showing to be functional, or is at least not idle in the genome. If the ENCODE project actually now shows that, say, most nucleotides play a role in multiple overlapping codes, wouldn't that make these beneficial mutations that we're talking about, that are actually not deleterious, to be at some level vanishingly rare? Because if more of our genome is functional, that means a mistake or a mutation on a functional gene. Wouldn't that just increase the level of degradation? Go ahead.
If we do figure out that the whole entire genome, or most of it, is functional, it's possible, yes, it's possible that these mutations could be deleterious or whatever, but it's also possible that some of these genes can mutate, or they can mutate, or they could, they can create a copy of themselves, and that function will still exist, and that the other copy gene can do whatever it wants, which could either increase or decrease the function. So if we do figure that out, it's possible that genes copying themselves or whatever could show that not every mutation causes a loss of function.
Okay, thanks for that. I think also because you talked about some of the flood evidence, the fossil record, because the paleocurrent data from the Mesozoic and Paleozoic rocks, they actually indicate a pattern of crossbeds and ripple marks that actually flow the span of entire continents in one direction during the Mesozoic, and a completely different direction during the Paleozoic. So my question in regards to that would be, if there was no global flood, so does it seem like you were fighting that in your opening, the currents of ripple marks and crossbeds should be randomly distributed, flowing from all directions. So how come that's not the case? Given a uniformitarian assumption, how come that wouldn't be the case?
Is this ripple effect like seen across the entire world? Like every single Mesozoic layer has this ripple effect. Is that true?
Yes, we see this pattern of ripple marks, and they're flowing the span of entire continents in one direction during the Mesozoic, and a completely different direction during the Paleozoic. So I mean, it seems consistent with a global model, but I'm not too sure how someone under a uniformitarian assumption would be able to explain a lot of the geology we see.
Well, I'm not an expert in anything. I have a little bit of everything. I'm not completely, I don't know about these ripple effects in these layers, but if a good amount of layers show this ripple effect, 90% or whatever, I don't say 90%, but like whatever you classify as pre-flood has all these ripple effects, and you can prove that these are different, then I don't know exactly how I can account for the geography of the continents and their I'm not an expert at geography. But,
yeah, no problem. Since we're still on the flood, and the CPT model is what I look to, how could the weak and more so snail pace, say, plate tectonics that uniformitarians look to, how could they have sent cool slabs of rock towards the mantle, or I should say the core boundary? Because it seems like only a strong force like the biblical floods catastrophic plate tectonics model could have actually accomplished that. Because we look to rapid plate tectonics, and that seems to explain the observation. So how does slow and steady plate tectonics explain that?
I mean, it is slow, but it is devastating. The damage a plate could do when it slides under another plate, it causes earthquakes. or when a lot of damage can happen, it's possible because the mantle is much, or the core is much hotter and liquefied. It's not as dense. The crust is possibly more able to go under it. And this is, I don't know how heavy these plates are, but probably tons and tons of weight is going into the effort into the core, which could push away this molten rock or whatever it's in.
Okay, and thanks for that. I guess, given all the evidence that I provided about, the Earth once being underwater, for example, a lot of these fossils that we see of, say, animals giving birth, fish being eaten, suggesting sudden and rapid burial, is that not consistent within a biblical-based model of a global flood? And if not, how does, somebody under a uniformitarian-based assumption explain this current data?
Got about a minute left. Oh, sorry, Siv.
I would say it works for either model. If fish is eating another fish or something, as rapid disaster can happen anywhere on this planet because there's thousands of volcanoes and who knows how many underground ocean volcanoes or whatever's in the deep could fossilize these animals quickly enough so that they eat. What I don't understand is that we don't find any like dinosaurs eating humans or something, or like they're in the stomach, or some sort of animal we would find at the top layers in the stomach of some other animal below it.
So based on what I said about the distribution of 10 seconds?
Yep.
Okay, I'm good then. I don't think I can formulate another question than that. Thanks.
You got it. Thank you, gentlemen. And by the way, everybody,